All right, welcome to another session of RTX Compare. And today we're working with Qwen3 14B, and this is with the Nvidia floating point 4 quantization. It's going to be running on that device right there, which is a Windows 11 desktop with a GeForce 5080 with 16 gigabytes of VRAM on DDR7. So it's a pretty fast device. It's not as great as the 5090, nothing really is. But I think it's adequate for this model. This model is, I think, 10, 9 or 10 on disk. So when you actually think about it, you're having at least, I don't know, 5 or 6 allocated to KV cache. So it's enough. It's enough space, and if you had obviously if you had 24 or 32, which is on the 4090 that we have upstairs, or 5090, it'd be much better. But then we wouldn't be testing this model, right? We'd be testing a bigger model. So for the purposes of the biggest possible model you can fit, at least as of today, for a 16 gigabyte um, GPU on a Windows device, this is about it. All right, so let's give it a spin. It's being served off of the LLM right here in this Docker container, and the CPUs are clean, right? I expect 100% of the load being on this GPU, and since we're doing it clean, we'll try to keep the context as small. It shouldn't have to spill over to the CPU or even use disk cache. All right, let's give it a run. Tell me all about. Let's open that really fast. Sorry about that. Tell me all about Tyrannosaurus Rex. I purposely misspelled Tyrannosaurus to see how we can handle it. There we go. There we go. As you can see, it just spiked up from 3% all the way to 94%. It thought for about 5 seconds, and all right, that's pretty fast, but not a lot of data. It's barely a page, and normally we're used to seeing a lot more than that on the different models. I'm not too happy with those results. Let's follow it up with another question. Whatever this supports the debate about T-Rex's speed. That was 10 seconds. Okay, a little bit more data here. That's good. This is more like it. Okay, that was about 50. Tell me more about T-Rex. Kind of, let's try to get it so that we have more basic information. All right, it's much better. It's much better. I got a little worried there. Usually those things happen when you have a context window that's kind of dwindling down, but that was the first query. Let's do it again, just for kicks. Tell me all about rhinoceros. I misspelled rhinoceros on purpose. Okay. If I meant rhinoceros, there we go. I did mean rhinoceros, and see what it does. That was kind of cool that it tried to go rag. Okay, there we go. Pretty fast. This is a solid 50. 45 to 50. Tell me more. Interesting how the CPU load is going up there. I'm a little concerned. But I think that's mostly because of Open Web UI as opposed to the actual LLM itself. Let's watch that again. See how that's CPU also spiked up a little bit, but the majority is being carried by the GPU. Yeah, still solid. All right, let's try tooling. Let's pick up our favorite file. Auto MPG. This is 398 by rows by 9 of car information. Analyze this file. Tell me all statistics for all rows and columns. Notice I misspelled the statistics. It's thinking a little longer than the other models. 10 seconds is about fine. Okay, good. That's really fast. Yeah, Qwen has been pretty impressive when it comes to coding. So anything where you're calling Python to actually analyze a file is it's pretty fast on Qwen. Can you visualize the data with a histogram or box plot? Oh, this is a good one. I don't know if this will work because, again, the context window is not that big, right? I think we have less than 6, and we're already opening up a file. And that sounds about right, see? It says it only contains 3 rows of data, which is incorrect because I know that this actually has a lot more rows. It's 398 rows. So yeah, this is just when you're losing context. So let's try that same thing over again. But this time go straight to it, right? Draw me a histogram of a sample of columns and rows. See what it does. So 10 seconds was our cap earlier. Let's see how long it takes this time around. Okay, so it says it actually can't create a histogram. Again, this is the first time I'm actually playing with this. But it did give some data. Oh, interesting. It should actually say we can't draw histograms. Let's have it generate code for us. Still thinking. It's definitely well past 10 seconds. Oh, but cool. It actually generates what looks like very close to Python notebook style Python code blocks. Oh, it even has a hyperlink. All right, let's now ask it about Tyrannosaurus Rex. Aha, see what happened there? It actually looked for a Tyrannosaurus Rex in the document as opposed to using its weights, right? Let's test it out again here. Because here we don't have context at all because it's fresh. We'll actually go to the weights and actually go and feed us the correct amount of information because, again, there's no context. Wow. Look at that. It's a new chat, but it's not properly recognizing it. So this time around, I'm actually going to copy Tyrannosaurus and spell it properly and see what it does. Tell me all about Tyrannosaurus Rex. Let's see if it actually goes to the weights. Okay. So it tried RAG, didn't find anything, so it went straight to a basic set of information, but this is still pretty sparse. We were trying Gemma earlier, and Gemma gave more than this. So I will do tell me more. And again, it's going RAG again, right? Query knowledge files. So yeah, I think it's wow, it's not a lot of context, but we're running out of memory here. I think it's yeah, this is the problem when you're so close to the cap. Again, this is a 12 parameter model, or 14 billion parameter model, and we're at 16 gigabytes of RAM, right? So not that much there, but let's try it again. Tell me all about Tyrannosaurus Rex. Tell me as much as you can with as much detail. See, it's going knowledge base. It's just going to RAG. So I think what's happening here is that we really kind of this is no longer the LLM. This is more system memory that has a problem, because again, we just never allocated. Well, whatever we allocated wasn't enough, because now it's actually bleeding over to I think CPU memory or disk memory. So yeah, definitely not happy here. Let's refresh. Let's switch to arena model. Say hello, and then switch back and see what it does. Okay, now we'll switch back to Qwen again, and then tell me a random fun fact about Roman Empire. Yeah. So definitely see, this is what's happening, right? So our initial query was good, but now when we're running, because we're running out of total memory, you pretty much have to reset the container and load it up from scratch and see what it does. Let's actually go ahead and try that. So I'm going to go here. I'm going to stop the container. So now it goes defaults back to Arena. Let's start it again. Okay, it's active. And then create a new chat. Refresh this for kicks. Let's try it again. Tell me all about Tyrannosaurus Rex. It's still not loaded up yet. This will take a second. Let's ask Claude really fast. Tell me when model is loaded up. No further waiting. I don't think so. I think that's probably cache. Check again. See, you actually restarted loading weights right now. It's not actually ready. The container got restarted and it's currently loading weights from scratch, 33%. So we're about a third through. So while that's happening, let's actually go and look for, let's go online. Show me a Qwen3 playground. Oh, these are all bigger models. I was kind of hoping to look for a smaller one. Let's try that. Qwen3 playground. I wonder if they have a playground here. Let's give it a try. I just want to see a playground. Oh, it's loaded. Okay, perfect. Let's try it again. All right. Tell me all about Tyrannosaurus Rex. Let's give it a look. Earlier it was a lot faster in terms of the thinking. Yeah, we're not in a good place, right? Because now it's saying that it's actually going through RAG now. So the model's really messed up. It's not, even after a restart, it's not going well. See? General information. Okay, let's give this a try. Again, this is a follow-up question. Okay. It's a little bit better. Speed is still good. I'll put a link on the description for the Gemma results, but I found the Gemma results to be a little bit better than Qwen's. And Gemma was at 12. So, yeah, imagine if you didn't have initial expectations, so you're just judging it off of the initial result, you wouldn't be satisfied. So I know it's capable of more comparing it to other models. So it's concerning to me that I had to really put an effort to find out this information. That isn't great. Yeah, see, RAM usage has actually gone up. So it's probably bleeding into system RAM. Anyways, okay, so I'll play with this more, but kind of just want to show everybody the token speed for this model. Qwen3 14 billion parameter quantized down to Nvidia floating point 4 on Windows 11. Thanks a lot.